In this video, I will break down how I made this flowing water animation in Blender and LiquiGen. I first covered the modeling of the flowing path, and then how I built the whole scene with the help of some assets and what shader and materials I used. Then I break down my lighting and color grading workflow, and finally how to set up the water simulation in LiquiGen and how to import it back to Blender. Sheesh! It's gonna be amazing! Before we start, I just want to point out that this is not a step-by-step tutorial. It's more of a detailed breakdown on how I made this animation. When I use assets and add-ons, I will be transparent on what I use, and I will try my best to guide you to some free alternatives or show you the free way. Okay, so the starting point of my Blender scene is basically a very big plane, just scaled pretty big. I didn't even apply the scale, I just realized. And we have one camera, and it is just going linear into one direction. I'm just gonna unhide the flowing path, the original flowing path, and we can see that in the camera view, the idea behind is that we have like these snake-like shapes, and the whole thing goes to the right, because then I don't need to bother with like infinity horizon stuff. So that's the idea behind it. Now to create this path is actually not that difficult. I'm just gonna place my cursor around here. And then in top view, I'm gonna shift A, mesh, and then single vert. If you don't have this, it's under preferences and then extensions and then extra mesh objects, just saying. So in the top view, shift A, single vert, and then now we have a single vert. We are automatically in the edit mode, which is perfect. And now we can press double E, which allows us to extrude an edge. And the idea behind this now is to create some sort of a low poly flowing path basically. And to make my life a little bit easier for this tutorial, I'm just gonna trace my original path, and you can do this too because I'm gonna provide the original path and the camera and the floor as a free blend file you can download, so you can also start with some sort of reference so you don't have to start from completely scratch. So now all I'm doing is just to extrude some edges and try to just trace the shape I just created for this project. You can use the shape as a reference, as I said, but you don't need to do it exactly as this. So now you should have something close to this, just a low poly version of like a flowing path. I'm just gonna hide the original one so we can only see our new creation here. I'm also activating the snapping and then snapping on faces and snap it to the ground because this is where it's supposed to start. Now to make everything smooth, the secret is to select every vertex and then Ctrl-Shift-B. This allows us to bevel the vertices to make everything like just curvy and smoothy. This is what we want. In this instance, I did like a global bevel, which I would not recommend in this case because I think it's much better to select an individual and then really figure out the bevel for yourself. This way you can make everything, just give everything much more variety, and it's also not that very difficult. Just select them. Do the shortcut and just adjust it, and with the mouse wheel you can adjust how many vertices you want. Okay, so now you have something like this, so everything is now smoothed out. Now select everything, and then we're gonna press E, and then we can extrude it upwards. Something like this works pretty well. And then I go to object mode and then shade auto smooth, and then I'm going to add a solidify modifier so we can add some thickness. We can see that there are some issues with normals, so we're actually going back to edit mode and then Alt N, recalculate outside, and now our solidify is fixed. Nice. And then finally I'm also going to add a bevel to make it more realistic and just nicer overall. Pretty cool. Okay, that's basically it about the modeling for the flowing path. You can always come here, select the top edges, and you can adjust the height of everything. That's easy. You can also come here, select a single edge, go to soft select, and you can still change the shape of everything. This was especially important when I added the column assets in my scene, and this way I was able to still adjust the shape of everything later with the soft select method. So that's maybe a good time to actually talk about the assets that I'm using, and we will leave the flowing path for now, but we will come to it back later. Now these are the assets I use in this project. So we have one column then we have like this capital on the column, and then we have this thing. Now these 3 assets are all from Max Hayes' Fantasy course, which I will link down below. This is where I got them, because they are part of the course, the assets, which is really, really nice. Of course, I know not everybody wants to spend money or can afford it, so I will actually link down below the guy who made these assets, who's called HB Project. He made these assets for Max Hay, and he made the video exactly on these 2 assets, so there is no excuse for you to not have it. There's no need for me to explain it, because he explained it much better than I could probably. But you can also make it easy. You can also make just a normal pillar like this, which is like really not that difficult, and you can make a very simple column capital, for example. There's no need to make everything super complicated. Now I will actually show you how to make this, because it's actually pretty interesting. So this is called a groin vault, and it's just 2 cylinders across and just merged together basically. So we could come here, Shift A, let's create a cylinder. The vertex count doesn't matter. I'm just gonna rotate it like this. I'm gonna scale this a little bit up. I'm gonna Shift D, and then I'm gonna scale it into the other direction, 90 degrees. So now we have this. Okay, and for both of them, I select them, Shift A, apply the scale just in case. Now I select any one of them, add modifier, a Boolean modifier. I'm gonna select the other cylinder. I'm gonna hide the other cylinder for a second, and now we need the intersection. Okay, now I'm gonna apply this, and now we have this cross section. And this is exactly what we need. Maybe merge vertices, something wrong. Okay, I don't know why, double vertices, but whatever. So I just need this. So now with these edges selected, I'm gonna press Shift D to duplicate them just on the spot. P, separate by selection. Go to object mode. Now I'm gonna delete these faces thing, because I don't need them anymore. Now we have this thing, which was kind of weird. No worries. Let's go to top orthographic view. Make sure, in my case, I have X-ray on, so I can select all the vertices that I need. Now I can select one of these sides, press E, and now I can extrude them out. And then I can press S, and then scale on Y in this case, for example, and then do it again. And this time I'm gonna select these, and I'm gonna extrude them into the X direction, and then also SX0. Now I have this. Okay. Now I'm actually using the hard ops mirror tool, but you can also use a normal mirror modifier. This makes no difference, honestly. So now I have everything mirrored. Okay, and now all I need to do is to delete these bottom vertices, and now we have this. Sheesh. Oh, that's pretty nice. Now we can come here, obviously, and then you can adjust the proportions. So let's say you want this to be more narrow, you want this to be a little bit more longer, whatever. Doesn't need to be like complete symmetrical, but this is how you create these 2 cylindric cross-section shape thingy. So yeah, I think this looks kind of accurate to the reference that we have. So we can see the thing we just created looks pretty much exactly like the original model, so the main shapes. The only difference now is that the whole model will have these extra details, let's say, which are not connected to the main shape or whatever, you know. You do not need to make everything in one mesh. This makes your life so much easier. So in order to create this, we can come to our newly created thing, and we're gonna steal this edge here actually. So Shift D, P, selection, and then we have our new edge. Now I can press E and scale it, and then move it down so the bottom is like kind of horizontal. It's not super important in this case. So something like this. Now we can add some add loops, so something like this, and then you can start moving stuff. So you can, you know, make something like this, or move this a little bit, maybe add one more again, and then here we're gonna move it up, you know, something like this. Looks kind of interesting. Then we can give the whole thing a little bit of thickness, something like this. Then you can continue adding like some loop cuts, you know, do this and then extrude outwards, do the same thing like here, extrude outwards as well. And then you can, for example, start, you know, beveling stuff like this edge, and then I'm gonna bevel it something like this. And then I'm gonna add a bevel modifier to the whole thing, make it not that big, give it a Control 2 to make it sub deep, make it smooth, and you can see it's like it's really similar to this. And obviously not exactly as this, but you get the point, right? It's not that difficult. Now to make these lines, there's actually a pretty nice trick. You can come here, also select these edges, Shift D, P selection. You get the point, right? It's always about stealing the edges. And you can come here, object, convert to curve, right? And in the curve, because now it's a curve, we can add a little bit of depth, and then we can come here and then convert back to a mesh. It's a really funny technique, honestly. And we can, for example, come here and then delete these vertices. It's maybe a little bit too much. We can, you know, give a little bit more geometry here. Delete these. Come here, boom. Now give it a Control 1. Now you have these. Pretty simple, right? And I mean, add a cylinder, add some walls, add this, you know, you can, I'm pretty sure, I believe in you, you can do this. It's not that difficult. In the next step, I'm gonna show you how I arrayed them, because I actually arrayed them with a collection instance geometry node setup, but there are other possibilities. Well, the easiest thing you can do is to merge all of these together into one single mesh. And then you can, you know, in theory, give it an array modifier, right? And then we can see, and then we can start arraying it. And we can see the poly count doesn't grow because of Blender 5.0, which is really useful. But you can see the performance is absolutely ass. It's really shit. Furthermore, we merge everything together, so we don't have access to, unless we go to edit mode. But this is also pretty unflexible, right? Going to edit mode, everything is super dense. Yuck. I don't like it, right? So there's a much better way to. So what I did was to use a geometry node setup, which is not that difficult actually. There's just a few nodes, right? But I still have access to the individual objects. It is very performant, as you can see. And the very cool thing is I can still use these empties to move my original position of my original objects, but my instance collection will not move. And this is such annoying. This is such an annoying thing if you do not know this trick. So if you don't care about this and you just want to do the array, be my guest. But if you're interested, I'm just gonna break it down very shortly. And if you're not interested, you can just go to the next chapter. So the idea behind this is to array a whole collection and not array an object. So I have a collection called main. I have a collection called pillars. And my instance object is in the end just a plane. I can move the plane however I want. It doesn't matter because I'm not using the group, the geometry node input. I just need an object somewhere to put my geometry node setup. And the setup is very simple. It's just an array on a line. And to make an array on the line, you just need an instance on point, and you need a mesh line, and you need something like into this instance. In my case, I have this collection, and I have all these parameters inside my group input, so I have access to them here in the outliner, in the properties panel, I'm sorry. And we can see if I select this object, I have my pillars. If I select this object, I have my main. And with this mesh line count and offset, it is just like a normal array modifier. So I have access to the count and I have access to X, Y, and Z offset. Sheesh, that's pretty nice. For the instance, I just said it's just a collection depending on what I'm using at the moment. So if I come here and type in pillars, then it is just at the same place. Now this is very interesting. I have a set position, a multiply vector, a vector multiply, and then an object info node. This object info node is also in my group input, and here I'm gonna use an empty. And this empty is exactly in the middle, or where my origin of my collection is basically going to be. And all my stuff is also parented to the empty. So if I move the empty, everything will move with it. And I multiply this by -1 on the B vector. And this allows me to, if I just only used my empties, I can move it and nothing here moves, which is so brilliant. I love it so much. But of course, if I move a single arch and not the empty, everything will move then. So this will still behave as you would normally think. And I separated between the main and the pillars, so I have flexibility to say, okay, you know what, I have these and I duplicated them, and then here, for example, I do not want the arch because, for example, this will fuck up my lighting from the left or whatever. So that's the main reason why I'm doing it, and this is honestly such a brilliant way to array your assets. Okay, enough about modeling and all of this. Let's make things a little bit more fun. Let's talk about lighting, texturing, shading, the good shit. Let's first talk about the scene, the world lighting. In this case, it's pretty simple. I just have an environment texture. In this case, it's a free from Polyhaven. It's called Shanghai Bund. And if we plug this in, we can see there's light. Now, I also use hue saturation and the mix color to desaturate this a little bit because I want more of a night theme, I guess. In the end, this is, I believe, 0.5 and not 1, but it's kind of a little bit too dark in the viewport, so I'm gonna leave it for 1 for now because I want to talk about the texturing and the detailing for the other assets. So now let's focus about the materials of the arches and the pillars. So let me actually select one of these pillars here, and we can see now we have this main material. If I uncheck it, we can see, okay, this is where it's affecting. Nice. Okay, let's break this down. First of all, this is the base principle, BSDF. Nothing crazy fancy, just a little bit of metallic, roughness a little bit down. I like to use a bevel node in this case, since I'm using cycles. This gives me a little bit of a nicer highlights on the edges, but it's not super visible, it probably doesn't matter. More importantly though is this ambient occlusion, one of my favorite nodes to kind of fake a little bit of occlusion. So if I plug in this color into base color, we can see there's a huge difference in the well, I guess in the ambient occlusion, right? Like it's what's supposed to do. Now this bunch of noise texturing, this is just to make these like subtle details, let's say. And the funny thing here is definitely the second noise texture into the vector. So that's, I think, really funny. So this is the normal noise texture. And if I plug in another noise texture with a color inside the vector, that's pretty nice. It kind of gives a little bit more detail, so even more than like turning this up. I thought it was actually pretty interesting. A little bit of color ramp shenanigans, mixing it together, you know, and then in the end you have something like this. Nothing crazy, honestly. And this I'm just gonna plug into the color of my ambient occlusion, and then in the end, this is my shader. I just noticed that you have this really strange edge here. I actually didn't notice that in my final render, but this is because we have like separate objects here, right? So what you can do is you can come here into from the X mapping, and you can move this until, you know, you have like some sort of this. It's much better than before. It's not perfect, but if there's vegetation, if there's fog, if there's light, nobody's gonna see it. Now let's talk about the tile material. In this case, I use a procedural material from Sanctus library. It's, by the way, in my opinion, a pretty goated procedural library. Worth it in my opinion. It's also not that super expensive. And in my opinion, the most important thing here was the color variation. Because I think this really makes it so much more interesting if you have some color variation into it. But I actually found out how to make this completely for free, because Blender actually has a brick texture. And if I plug this in, you can see that it's pretty much the same thing, right? So let me break this down. Okay, so if we create a new brick texture and plug this in, we can see that this is what Blender is doing. Now this is already pretty close to tiles, but we can see there's like a little offset and whatever, and it looks like a brick wall instead of tiles, right? So what we now do is get a mapping, get a texture coordinate UV, and then plug it into the vector. Now this is much better from the scale already. Now if you compare this to the final brick texture, we can see that this offset is really important. I make this 0. In this case, now we have tiles. Now for the coloring, this is where the color variation comes in. Now I have this greenish color. This is the hex code for it. And I just make the second one just a little bit lighter or darker. So not a really huge difference, but you will definitely see it in the end in the render. This I will make white or grayish, something like this. Make sure that this is like really, really low, super low. Actually, it can be a little bit more lower. We turn off the scale. That's really important to get the scale of this right. Now we can see the color variation working as well. I think, yeah, I mean, we can just use the normal brick, the real brick texture, plug it into the principal BSDF, a little bit metallic, roughness down to make it shiny, you know what I mean? Sick, sick. You can just copy the values if you want to. And yeah, this is how you create the tile material. Pretty simple. Now for the UVs, I was extra lazy. I just come here, and just make a cube projection, scale this bad boy up. There we go. It's absolutely not optimal, and you will definitely see some artifacts, but I didn't really bother with it. You can make, I mean, this is a really simple mesh, right? You have like, everything is like quad topology. You can just make a cut and make a proper UV unwrapping. I just didn't really care. What you gonna do? Call the police? Anyway, you will most notice some shenanigans at the top if you do the simple UV, but in my case it actually didn't matter, because in the end I actually used this, and all I was doing was I was just separating the top part from the lower part. Since everything is quad, just make a loop cut, super simple, and the top one has a, you know, shiny white material to reflect a little bit more. And in my opinion, this looks really nice. So tiles, then the snake tiles, and then this white thing on the top, my opinion, pretty nice. And that's basically it about the materials and texturing for this whole project actually. In the next chapter, I'm going to break down my workflow for scattering my plants and vegetation with GeoScatter, and also a little bit and the assets I'm using with Sweeper's Arborea add-on. The first step to scatter my stuff is to create a new geometry here, which is just, you know, tracing the path of this flowing path, and I can just move it up a little bit so the plants are not starting from the ground but a little bit above. And to make this, it is not that difficult. We go to edit mode and we can, for example, grab this edge, and then we come here, press Control, and then we have this edge, then Shift D, P selection as always, right? And then this newly created thing, I'm going to edit mode as well, press E. I'm just gonna extrude it in this direction, come to top orthographic, scale it a little bit, maybe something like this. Now this doesn't need to look good. All it needs to do is to, you know, cover this angle so it's you know, exactly as the flowing path. And here I just need to have a like space basically. And I know from the camera that I just need this. That's all I need. And I do the same thing from this side. So I'm just gonna grab this, edit mode, then I'm going to grab this one, so completely around this thing, and then also Shift D, P selection, you get the point. E, put it in this direction, a little bit to this direction. So now I have this. Now I can scale it up or whatever, just so I can cover enough space. So I can scatter my plants. If I compare it to the original, okay, the only difference is then I can come here, grab these, and then just do something like this, just so I have enough space. Okay, doesn't need to look good. Boom, that's it. Now I select this, Control J to combine them, apply the scale just in case. Now we're good. Now these are the plants asset that I use in my project from Sweeper's Arborea add-on, as I mentioned. In this case, I have one bigger plant, this fern, one flower, grass, and 2 brush types. That's all. And if you're looking for a free alternative, I will link you down below a free plant library pack from GeoScatter, which I think is really good, even though it's free, but obviously it's not that quality of Arborea. By now, if you know me, I like to use GeoScatter to scatter my vegetation. There are free scatter alternatives as extensions, I link you down below, and there's also the new scatter on surface modifier in Blender 5.0, which can also be worth it and can also be used, which is also completely free and comes with Blender, but I just like to use GeoScatter, so that's what I use. Now, how I use GeoScatter, I'm just gonna break it down really simple, since this is not a GeoScatter tutorial. I mostly just use manual scatter. So what I'm doing is, in GeoScatter, I make sure that my emitter object is the plane we just created before. Now I select any of my vegetation asset, for example this one, and then I'm gonna go to manual scatter, scatter my object, and now I can start scattering my object manually one by one, which is just really useful. And when I'm done, I can always come into enter menu mode again and then delete the stuff again. Usually what my workflow is, I start with the lower ones, like the smaller ones, the fern and the grass, for example, to cover most of the ground. And then I'm gonna add, let's say, the bigger ones, and then the another bigger ones, and then I make sure like the bigger ones in the back are like covering a lot of stuff. So if I turn on my pillars again, you can see I just make sure that, you know, there's no empty space, and it doesn't all need to be scattered. For example, here I just place some rocks to cover more, you know, stuff, keep some variation. And for example, in the background, you can place some individual tall trees, big trees, whatever. Not everything. You can make a hybrid of scattering stuff, you know, and then placing stuff manually for different objects, whatever. You know, there's no right and wrong. You just make it look nice. I also use Arboria's vine generation tool, which is really useful because I was able to get these nice vines growing around these pillars. And the good thing about them is that I can just draw them. And they are, you know, working with the instances and stuff. So that's really useful, as you can see here. Now, I actually found a free YouTube tutorial how to make this kind of drawing vine generation stuff. I link you down below. It is honestly not that difficult. So you can check it out if you want to use it, because you can definitely not do with scattering. So that's basically everything about the vegetation in this project. In the next chapter, I'm going to cover how I made the lighting and also the color grading. Let's go. First, in the world settings, I'm going to lower this again into 0.5, as I mentioned before. And the first step is to create a big cube. And this cube, we are going to add a principal volume. And this principal volume is going to have this hex color and a density, a very low density of 0.02. The anisotropy is about 0.5. And this is our volumetric fog in our scene. And this fog is very important because this allows us to create these very nice God ray-ish style, let's say, and without the fog, with these spotlights and without the fog, this wouldn't work. So the big question is, how does the spotlight work? Now, these spotlights, these four, are all the same spotlight. They're all connected with Alt-D, because you can also Alt-D lights if you didn't know. I'm just gonna hide the other ones. And let's just focus on this one singular. If I uncheck use nodes, we can see this is the, let's say, the normal spotlight without anything. There's a huge amount of power in the spotlight and there's a very low radius, and we have this angle and this blend value, okay? And the most important thing about this is definitely the use node. So if I press use nodes, this is the node setup. The main player of this is a Cortex texture. If I plug this in, we can already see an immediate effect. And this Cortex texture looks like this. And I swear to God, you can just type in Cortex texture in Google, grab any one of these. I don't care how you get it, but this is the type of texture you need, okay? Now we need a mapping node and a texture coordinate node. And we need the normal input from the texture coordinate into the vector. Plug this in. Now we can see it. Now this looks proper. Now I have on the Y location, I have a hashtag frame divided by 450 because this will give me then a slide animation. If I delete the driver, you can see this is how the light will be influenced, and a hashtag frame 450 was just the perfect speed, let's say, for this project. Now you can also mix in a mix vector with a noise texture. You can also animate the W of the noise texture, and you can plug this into the vector instead. So the mix, the vector is very sided to the original texture coordinate and just a little bit towards, just a little bit towards the noise texture, because if it's too much, then you won't see anything. And this is just another option to make further customization, to make it more random, whatever. But this is how it works. So now I turn back on the other spotlights. There's also one at the back, so we have everything illuminated. This is the main light setup, I would say. Then I have some secondary lighting with some area lights, and this is also the same principle that I just make a bunch of different small lights instead of one big light. In this project, it just worked well. The area lights are all the same, and these are the values for the area lights. You can just straight up copy them. But yeah, so that's basically the lighting setup for this project. A very important step is the color grading, so I can go from here to here. For my project, I always use Render Raw, which is a very nice add-on to make color grading. This makes my life so much easier because it's basically Lightroom but in Blender using compositor nodes. Now, this is not a Blender Raw tutorial, and this is a paid add-on, so I will not go into the in-depth too much. And I will also show you how to make this, let's say, a free version of this in a second. I just want to point out that there are 3 elements for color grading. First of all, we have the values, so we can control the contrast of the whole scene. Then there are the colors, mainly more saturation, the effects, which is glare and some chromatic aberration. So I tried my best to come close to the Render Raw version with some basic notes, and this is the setup. I think I mean, it looks good. It's probably not exactly the same as the Render Raw version, but whatever. So let's go through them one by one. The color correction node, I mean, it's in the name itself. I ignore everything, and I am just in the shadow tab. And in the shadow tab, we have the saturation value, and this is probably the main color, the color thing. This contrast is very sensitive, so I'm gonna hold shift, but I can control the contrast pretty well. You can also play with the gamma in order to play around with the contrast as well, but I think this looks pretty fine. Now there's this color balance, and in the gain of this, because the gain is for the low values, we can, you know, increase the blue values a little bit, not too much. And this way you can get a little bit more blue in the shadows, but it is a little bit too much, and I think Render Raw makes it much better with their color thing. So you can do it, you cannot do it, whatever. I also use some RGB curves with this sort of profile. This also helps a little bit to make the contrast a little bit more interesting. Then there is lens distortion, and in lens distortion we have this dispersion for these chromatic aberration effects. And lastly, there's this glare node, set to bloom, very important, and this is how we get these shiny highlights. And that's the color grading. And finally, in the last chapter, let's cover how to make the water, and then we are finished. Sheesh! The first checkpoint for the water is this. We want to have in LiquiGen one emitter that emits water, and we have our collision flow object, and we have a collision pillar object, so we can see that the water is interacting, the performance is good, etc, etc. This is the first goal for the water. So let's jump back to Blender and see how we can do this. Back in Blender, we have the original flowing path object where the top is still merged together with everything. Everything is clean. Now this export mesh, this is the mesh that you've just seen in LiquiGen. So this is what I use in LiquiGen as a collision object. If we go to edit mode, we can see that this is decimated because the less geometry LiquiGen has to process, the smoother our water sim is going to be. So this is very important that we decimate it. And I added this ramp up here, so the water can have a little bit more space to collect here, and it doesn't oversweep the whole scene basically. So this is why I'm adding this. Now doing this is really simple. Let's take this, Shift D, just make a duplicate just so we have a safe copy just in case we fuck up. In edit mode, I come here to the side view, make sure I am in X-ray so I can select all these vertices here, E, and I can extrude them to the top. Take these and can move them to the top a little bit so I can make some sort of a better transition here, something like this. Then I'm gonna come here and then decimate that. We can see here this is the face count, and I'm gonna lower this until we have, I think my original has something like 14k face count or something. So we can lower this to a really low value, something like 6k faces. So maybe something like this until the shading starts to break. yeah, I think this looks good. Then we're gonna apply this gentleman here, and we come to edit mode. We can see this is the decimated version. Now we can come here and merge by distance, just in case something was going wrong. But this is now our collision object with 12K faces, much better, way better performance. Trust me, this is worth it. Next, we're going to do the collision for the pillars. So in my original pillar object, I'm going to duplicate with Shift D one of the pillars, make sure that this is outside the collision because of our geometry nodes, instance array, whatever. Now we have this singular pillar, go to edit mode, and then I make sure we're gonna add a loop cut somewhere, yeah, somewhere here where we know the water is not gonna reach that far. And then I'm going to make sure to delete everything above that. I'm going to isolate the view. So now we have this, okay. Now, very important for all of your collision objects in LiquiGen, make sure that they are closed. So I'm going to select the top edge loop with Shift Alt, double click, and then I'm going to press F to fill the face. And at the bottom we also have a hole, so I'm gonna do the same thing and then press F. So now everything is closed. Very nice. Now this is way too high poly dense for collision, so we're going to do the same trick, decimate, and we are going to lower this a lot, something maybe 700s, something like this, and then we're going to press apply, and now this is our collision object. Now I'm gonna take this and I'm going to try to place it where the original pillars are in the render, so the water simulation is as close as possible to what we see, right? Now, because of, I'm just gonna duplicate it and do it to the other side. What I want to say is that because of the array, the geometry nodes array thing, you cannot apply it, so I'm actually eyeballing it. It is not a big issue. Honestly, it does need to be perfect. So I'm gonna go to edit mode. I'm gonna in object mode, sorry, Control J to make them to make both of them in one object. And in edit mode, I'm just gonna shift the. They're all in the same Y dimension, so I'm just gonna need to translate it into the X and then do this. I mean, it's not that difficult, honestly, right? Now we have something like this. So we have our flowing path collision object and we have our pillar collision object. Both of them are very low poly, and I'm going to export them one by one. So I'm gonna go select this, go file, and then export for FBX. You can name it however you want. Make sure select object is selected here, no animation, and the same we are doing for the pillars. And then we are going to LiquiGen. Now my LiquiGen project looks maybe a little bit complex on the outside, but it is not that difficult. If you go open a new LiquiGen project, you can see that you also have a bunch of different nodes already, and you will notice that most of them are very simple. So you can start with a new template, fresh model like this. Don't start from completely scratch, please. And then, so in the real project, you can see that, for example, the scene, the render, the export image, camera, skybox, this all is completely useless for us. We don't need it. And we have export particles, export mesh, very simple. And this is where, let's say, the magic is happening. So let's go through them and see how it works. So let's ignore everything that is grayed out and this right side for now. So we have the core of it, the simulation. So this is the most important thing. Now in the simulation, very important, the voxel size is this. Do it like this. This is very important. Step rate 50 Hertz. I will show you later why. Substeps 1. The higher the number, the more accurate it is. The lower this number, the more accurate it is as well. But like I said, about performance, in my opinion, is really important. This is the maximum numbers of voxel particles and triangles. You can copy them. Depending on your computer, maybe you need to lower them. But in my opinion, these are absolutely manageable. I will make 100% flip ratio. And I also want to simulate particle lifetime. And the rest, I think I didn't touch. Now at the moment we have one emitter and we have this primitive, okay? And if I press play, we can see that water is flowing. Sheesh, that's pretty nice. In the emitter, I mean the primitive is just a cube with these values. The bigger the cube, the more water you have. Now in the emitter, we have this. So we have the emission location into volume, we have a continuous generation, and this is the density of 0.5. We have a lifetime range from 0 to 40 seconds. And there's also this stickiness that I turned up a little bit, because this helps the water to be not that explosive, let's say. It's maybe not that realistic, but in my opinion, it was really useful. If you want to make more water, you can always come here, make the flow rate higher. Like I said, these are just my numbers. You can feel free to play around with them. The goal for you is not to make everything exactly as I do, but I will just show you the most important settings so you have an easier time. I'm trying to replicate what I had, right? So this is my main goal for this video. Now next, talk about the colliders. We have 2 colliders. Well, surprise, right? One collider is the pillars, and you can see here I just imported the tower FBX, I just call it. So this is the pillars, and this is the flowing path FBX. And if we play it, we can see this is working very nice. So this is probably so if you reach this far, there's basically nothing that can go wrong anymore, honestly. I have a relative resolution of 50% for both of them. This also makes the performance a little bit better, and we can see this is now working pretty well. So I was experimenting a lot with this project. You will get the short and precise version. And so I started with one emitter going from here, and I was like, okay, this kind of working, but you know, my camera is here, and here I have no water anymore. And I was like, how can I do this? So there are a few ways we can improve this, so to make this the final water flow super nice. The first solution is to make another primitive as a collider, and this is in the back here. What this does is it kind of collects the water here, and this water then flows back, so we have just more water overall. So that was really nice. And the most important thing is that I just figured out that if you just make more, instead of just one big emitter, basically, you just make few smaller ones, and this was working super well, because suddenly you can see I have like 4 or 5 colliders, and with each providing more water, suddenly I was able to make the flowing path scene just much more consistent, let's say. So this was the lifesaver for this water simulation, basically, to use more than one primitive. You can experiment obviously however you want, and in the end these are just basic cubes, that's it. For these 2 primitives, for example, in the back, they have another emitter, and everything is the same. The only difference is that the life range is a little bit lower, that's all. And the reason for this is because the camera starts here and goes here, so they don't need to, you know, create water for that long. But for example, this emitter, the water has to travel from here to all the way to here. The reason why I use the lifetime range is so I can just, you know, erase a lot of water that I never see, never use. And this is really important to save performance. There's also this drain, this cube with this drain at the end. So the water is basically getting erased by the world, which is also pretty nice. This also comes with the default project, so it's pretty easy to set up. In the next step, I added some line forces, 4 of them, one, for example, going from here, one going to here, one going to here, one going to here. Just a little bit of support to make the flowing a little bit more faster, a little bit more directed, let's say, so just give the water a little bit more direction. And lastly, but very important, the white water. Because this is how we create the white water particles now in the end, which we can export into Blender. And this is now, I just love it. Every time I see it, I'm like, sheesh, that's crazy. I fucking love it. Anyway, so these are the values that I use. Very important is that I do not simulate spray. I also do not simulate the bubbles. I only need the foam, because the magic behind it, or the trick behind it, so everything works, is to, like, this is very performance heavy, and you do not want to export more than necessary, because then your Blender is going to suffer. And too many particles does also straight up look ass in the final render in Blender. So it's kind of really about experience to know what to export, what not to export. Like I said, we only need the foam, and for these values here, everything I think doesn't quite matter. The most important thing, for example, trapped air, everything is 0 because there is no trapped air emission. The most important thing here is the wave crest and the range of it. So if I crank this to 0, there is nothing anymore. And if I crank this to 100, then we have our waves back. So what I'm looking for are waves, right? There are also bubbles and spray, but like I said, you're not going to see them as well in Blender, and they're just a performance killer for no reason, from my experience at least. So in the next step, we need to export, and we have 2 export nodes for this, one for particles and one for mesh. Both of them we are going to export into the Alembic data file. First, let's see the mesh. So for the export, I want to start at frame 1000. I don't want to start at 0, obviously, because there's no water. The numbers of frames are 400 in my case. My animation is not 400, but I just export a little bit more than necessary just in case. Now, the frame stride and the composite frame rate is very important. The reason for this is that our animation, our simulation is 50 Hertz. Why 50? Because the default Hertz in LiquiGen is 60 Hertz. Now 50 is very close to 60, and I'm doing 50 because our animation in Blender is 25 FPS. Now the frame stride helps us to divide so the speed matches basically from LiquiGen to Blender. So our 25 FPS Blender scene with the frame stride of 2 will equal the 50 Hertz in our simulation, and this is what we need. And this composite frame rate is very important because if we check it, then our water, the exported water will be exactly 400 frames in Blender. Otherwise, previously LiquiGen didn't offer this, and this was kind of a head mech to do. Unfortunately for the particles, there is no composite frame rate, so we still need to do it, but at least we only need to do it once and not twice. So for the particles, we also do the same numbers, frame stride 2. You can then choose a directory, export the stuff. Will probably take maybe 10-20 minutes because this is a little bit bigger water simulation, but still very fast compared to no GPU accelerated water simulations. Okay, back in Blender, I can now drag and drop my Alembic, my ABC water mesh. It is very big, don't be surprised. So I'm just gonna drag and drop it into Blender. I make sure that set frame range is deactivated, and then I go to import Alembic. This might take some few seconds, but it shouldn't take too long. Now this is imported, and we can see this looks like it's supposed to look like. So this is really good. We can scrub through the timeline carefully, and we can see the water's also moving. As I told you, the project is in 25 FPS, so we can test. If we go to frame 399, we can see the water's moving, and if we go to 400, it will stop. So the water is exactly 400 frames, as I told you, from LiquiGen, so this is perfect. Now if I go to cycles, we can see that the water at the moment has no shader, and that's pretty much the only thing that we need to do for the water. So I'm just gonna give it the water shader that I use in my end project, and we can see now this looks like water. Very nice. Now this shader is very simple. So the main thing of this is just a principal BSTF, and this principal BSTF is just grayish, bluish, grayish. Everything is like super low. Make sure that I decrease the alpha just a little bit, so that makes it easier to see through the water, and the transmission is really high. There's also a principal volume. This helps us to give it a little bit more coloring and more depth to the whole thing. But the most important thing is actually this setup here. You have a mix shader with a light path, and use the is camera ray into the factor, and use a transparent BSTF. And this is really important because this will make your water look like water, because then the water itself won't cast shadows and you won't have any strange artifacts with the water mesh. Trust me, just use it and you will see your water will look much better, as you can see here. And the only thing now is to take care of the white water particles, and then we are done. For the white water particles, is literally the same thing. I'm just gonna grab my particles ABC data, just gonna drag and drop this in. This is much lower than the water mesh, so this should be very quick, and you can see now we have the particle. And I'm just gonna hide the water so I can scrub through the particles without my Blender crashing, and we can see it is working, it is moving, but we can also see that this water stops after frame 200. This is obviously a very big issue and kind of annoying that the water mesh has this new function that you can render it out with the perfect speed, but for the particles, unfortunately, we still need to fix it manually. No problem. So select the form, the white particles, and then inside the constraint, in the time, I want to make override frame. So now this is checked. So everything now is at frame 0, so the particles won't move. So let's switch this to our graph editor. Now in the graph editor, we make sure that this is unchecked, the show only selected, because for some reason this is in the world or whatever. If this is unchecked, if this is checked, you won't see it. Now these two are old particles were already fixed, so we can ignore this for now, but this actually shows what I'm doing, because I'm just gonna drag this until frame 400. So let me show you. So like I said, just ignore this for now. We have the time, frame override 0 at frame 0, and I'm just gonna press I to make one keyframe. Now I go to frame 200, because this is where the last frame is. I'm gonna type 200 in, and at the moment this is basically the same thing as we just imported. And to make it slower, or to match the speed for the water, all we need to do is make this so gx, and we're gonna translate this to 400, right? It's, I mean, pretty logical. So now the particles is half the speed, and now it should match the water. And if we turn it on, we can see that this is now working. So the water and the particles now at the same speed. In cycles, we can see now that this is working. We have the particles, but we are not completely done yet. The last step is to add a geometry nodes modifier, and I have this white water system, and this is very simple. So we have just point to vertices, mesh to points, and this way we can control the size of our particles. So if I make this, for example, 0.8, we can see we have like really big particles. So this is the nth number that I use. This worked really well. Then I have a set material node. I'm just gonna plug this into the Groot input, so I can now type in any material in my scene. And if we look at the white water material, we can see that this is basically just a principal BSTF, a little bit alpha down, a little bit of transmission. That's it. So if I make this red, you can see we have, it actually looks pretty nice. And if we go back to the geometry nodes, there's also this bake. This makes the viewport performance a little bit better, but it's not super necessary, so you can ignore it. So it's basically only 3 nodes, and that's basically everything about this project. So if I just unhide my sweep collection and my geoscatter collection, we have everything in place, and I would say that's a really nice project. And I'm really happy, and thank you so much for watching. Lastly, maybe I can show my render settings. So I just have the default noise threshold. I have these settings. Oh yeah, it might be important to turn up a little bit the volume and the transparent. And I exported with 700 samples. One frame took me about 2 minutes, and the whole project took around 13 hours to render. A little bit high, but in the end, I am really satisfied with the results, and I hope that you found this video really helpful, and I would really appreciate if you maybe drop a comment or hit the subscribe button, because this would really help me out. And well, I would say that's it for me, and see you in the next one. Bye bye.